7, 5, 9,
8, 11, 12, 15,
13,
16, 14, 2, 3, 4,
1029.
1.
Hello and welcome to video class. First of all, let me explain what this tape is about. GCSE Maths is split into 3 levels and the names change depending on the examination board setting your exam. This tape covers higher level, otherwise known as level Z, level R or 3. Now if you sit this exam you can gain a grade A, B or C. The 2 other levels are Foundation and Intermediate, which are covered in other tapes in this series. But more details about the exams, together with some extra tips at the end of the show. Now this is meant to be a revision tape or a reference guide, and although we would like it to, it can't replace practice and even more practice. Now the beauty of this tape is that you can pause the teacher, and how many times have you wanted to do that? Yes, very funny. Now, if you don't understand anything the first time around, and let's face it, who does, then you can pause to have a think or rewind to have another look. Or rewind to have another look. Do it as often as you like. The important thing is that you understand it in the end, and that you try as many examples as possible. At the end of each section, I ask you to stop the tape. Of course, you can carry on to the next section, but if you do stop the tape, you can take a breather and think about whether or not you understand it properly. Well, now is the time to start. So here is section 1.
6, 2, 3, 1, 4,
7, 5,
9, 8, 11, 12, 15, 13, 16, 14, 2, 3, 4,
1029.
1.
There are basic tricks which you have to know about when you handle numbers. For instance, one way of simplifying numbers is to use significant figures. This number has 5 significant figures, 1, 2, 3, 4, 5. To reduce it to 4 significant figures, look at the 5th figure. If it's 5 or more than 5, add 1 to this number. Well, 1 here is less than 5, so this becomes 673.5 to 4 significant figures. Doing the same process again, we have 674 to 3 significant figures, 670 to 2 significant figures, and 700 to 1 significant figure. If you're multiplying and dividing numbers, then you can just forget whether the numbers are positive or negative until right at the very end. The rule you must remember is this. If the 2 numbers have the same sign, then the answer is positive. If the signs are different for the 2 numbers, then the answer is negative. In this example, the signs are different, so the answer is -8. A number is squared when you multiply it by itself. It's written like this, 3 squared. That's 3 times 3, which equals 9. There are also cube numbers like this, 4 cubed, where the number has to multiply itself 3 times. 4 by 4 by 4, which equals 64. If you want to go to a higher power, like 2 to the power 5, then just increase the number of times you multiply the number together. So 2 to the power 5 is 2 times 2 times 2 times 2 times 2. 5 2's all multiplied together, which is equal to 32. If you go one stage further, you can say 2 to the power 5 is equal to, and start bracketing the 2's. So you have 2 times 2 in one bracket, and 2 times 2 times 2 in another bracket. Again, 2 to the power 5 is equal to 2 squared, because that is in one bracket, and times by 2 cubed, which is in the other bracket. So if you look at this, you find something interesting has happened. 2 to the power 5 is equal to 2 to the power 2 plus 3. So if you want to multiply two numbers together, as long as the base number is the same, in this case the 2, then you just add the indices. In exactly the same way, 5 to the power 3 multiplied by 5 to the power 7 equals 5, and you're adding the indices, to the power 3 plus 7, which equals 5 to the power 10. Likewise, if you have a division, you subtract the powers as long as these base numbers are the same. So 2 to the power 5 divided by 2 squared equals this. Looks like a load of gobbledygook, but it is right. If you cancel some of the numbers, cancel this with this one with this one, you're left with 2 times 2 times 2, which equals 2 cubed. So 2 to the power 5 divided by 2 squared equals 2 cubed. You have subtracted the indices. These are some more things to learn. A square root of any number can be written like this, or as that number to the power 1/2. Now, if you're asked to calculate the square root of 12 plus 24, always work out the bit under the root sign first. So, the square root of 12 plus 24 equals the square root of 36, which is equal to plus or minus 6. The square root of 12 plus 24 does not equal the square root of 12 plus the square root of 24. If you do that, you'll get the wrong answer. Try it. In a similar way, a cube root is written like this, or as that number to the power 1/3. In fact, the fourth root is to the power 1/4, and that continues on for any root. The reciprocal of a number is 1 over that number. If the power has a minus sign, then it means the number is written as a reciprocal. So 3 to the minus 4 is 1 over 3 to the 4, or 1 over 81. Now, any number to the power 0 is 1. It doesn't matter how big the number is. If it's to the power 0, then it equals 1. Let's look at something else. Raising a power to a power. Say 3 squared all cubed. Now that's equal to 3 squared multiplied by 3 squared multiplied by 3 squared. And by adding the powers, we have 3 squared all cubed equals 3 to the power 6. Now, the faster way of doing this is to know that you should just multiply the powers inside and outside the brackets. Let's try this example. A to the 3/4 divided by a to the half. Think carefully and use the rules for dividing here. A to the 3/4 divided by a to the half becomes a to the 3/4 multiplied by a to the minus a half, or a to the 3/4 minus a half, which equals a to the 1/4. A number like this is very hard to write down. However, any number can be written in what's known as standard form, and this is how you do it. Put a decimal point in here after the first number, and that gives you 4.63. Then you need to multiply it by 10 to the power of something. So we'll just put multiplied by 10, and we're looking for a power here. Well, the decimal point has moved from here, how many places? 1, 2, 3, 4, 5, 6, 7 places. So that gives us 4.63 times 10 to the power 7 in standard form. In the same way, for small numbers, you find the number between 1 and 10, and then count the number of places that the decimal point has moved. So we say this is equal to 6.79 multiplied by 10 to the power something. This time the point has moved from here 1, 2, 3, 4 places backwards. So we say minus 4 is the index number. So this is equal to 6.79 multiplied by 10 to the power minus 4 in standard form. Okay, now you know some of the rules, you should work through some examples by yourself.
4, 3, 2, 1.
Numbers may seem to be just an endless string of figures, but if you know where to look, there are all sorts of hidden patterns to be found. Some patterns we all know are even numbers, 2, 4, 6, 8 in a row, and odd numbers, 1, 3, 5, 7 in a row. But there are lots more which you should know. So pause after each one to learn them. The first is triangular numbers. If you can draw any number of dots in the form of a triangle, then that number is a triangular number. 3 is a triangular number. So is 6. And so is 10. Square numbers are numbers which result when any number is multiplied by itself. 4 is a square number because it's what you get by multiplying 2 by 2. 9 is 3 multiplied by 3, and 16 is 4 multiplied by 4. So this is a pattern of square numbers. The next thing to think about are cube numbers. 1 is 1 cubed, 8 equals 2 cubed, 27 equals 3 cubed. So 1, 8, 27 and so on is a pattern of cube numbers. With Fibonacci numbers, you get any number in the list by adding together the 2 numbers before it in the list. So 3 is what you get from adding 1 and 2. 5 from adding 2 and 3, and 8 from adding 3 and 5. So this is a sequence of Fibonacci numbers. And that's number patterns.
Five,
4, 3, 2, 1.
These are fractions. A fraction is just a part of something, like a quarter of an hour, a third of a bottle of milk, or half of your savings. You might be asked to reduce a fraction to its lowest possible terms in the exam. Now, you might end up with an answer like 60 over 75, which, although it may be correct, isn't a neat answer. To put it in its lowest possible terms, you keep cancelling by dividing the top and the bottom by the same number until it can't be cancelled any further. Right, if we cancel here, 3 will work. So 60 divided by 3 is 20, 75 divided by 3 is 25. So that gives us 20 over 25. Well, we can divide it again, this time by the number 5. Cancel here, 20 divided by 5 is 4, 25 divided by 5 is 5. So we have the fraction in its lowest possible terms, which is 4/5, because that can't be cancelled any further. Remember, before you can add or subtract fractions, they all have to have the same denominator, or the same bottom. So if you have a sum like this, you'll have to make equivalent fractions with the same denominator before you can add them together. Here, make the fifths into tenths by multiplying the top and the bottom by 2. We have 6 tenths plus 1 tenth, which equals 7 tenths. Sometimes questions can be more like puzzles. Here's a typical exam question. If I use 3/4 of a tank of petrol and have 2 gallons left, how much petrol did I start with? Well, if 3/4 has been used up, then there must be 1 minus 3/4, that's 1/4 left. So if 2 gallons equals 1/4 of the tank, then the whole tank must be 4/4, and that's 4 times 2, or 8 gallons. So a full tank was equal to 8 gallons.
five,
4, 3, 2, 1.
Percent simply means out of 100. So if you got 75 out of 100 in an exam, you'd have 75%. 75% equals 75 over 100 as a fraction, which equals 0.75 as a decimal. They're all equal. The percentage sign is nothing more than a shorthand version of writing out of 100. And remember, a percentage is always of something, of a price, marks, or a weight. Percentages often turn up when you go shopping. If a shop has a sale offering 10% off and the original price of the top you want is £4.50, what is the sale price? Well, 10% of £4.50 is 45p. So the sale price will be £4.50 minus 45p, which is £4.05. One thing can be compared to another by being given as a percentage of the other, but both must first be put into the same units. For instance, if you have to calculate 60 pence as a percentage of £5, then you do it like this. The £5 is first turned into 500 pence. So put 60 pence at the top and divide it by 500. Now multiply the whole thing by 100%. The next thing you do is cancel down. So 100 divides into this once. It divides into 500 5 times. 60 divided by 5, you cancel the 5 there, that gives you 1. 60 divided by 5, that gives you 12. So 60 pence as a percentage of £5 equals 12%. Let's say that you have to divide 8 sweets in the ratio 1 part to 3. First of all, work out the total number of parts by adding the numbers in the ratio. So the total number of parts is 1 plus 3, or 4. The 8 sweets are first divided by 4, giving 2 sweets in each part. It's now easy to divide them up in the given ratio, 2 here and 6 here. Maths. Even if you can't live with it, you can't live without it. If you borrow money from somewhere, as we all do, then beware. If you don't want to end up with money problems, then you have to know and understand interest. Mark takes out a personal loan of £2,000 over a period of 2 years at a rate of 12% per annum. How much interest will he pay? Well, the interest payable is equal to 12% multiplied by £2,000, that's the loan, and that is how much interest he'll pay each year. So in 2 years, he pays 2 times that, which equals £480. £480, that's a lot of money. And remember, Mark also has to pay back the original loan, the £2,000, if he wants to settle his debt. Compound interest is the interest most likely to be paid to you by banks and building societies, and this is how it works. £100 invested in a bank account on the 1st of January, year 1, and the bank account pays 12% per year. Simple interest is paid to you, and this is then added on to your principal amount, the money you've invested. So on the 1st of January in year 2, £12 interest will be paid into your account. So the new principal amount is £112. The next year, the interest is paid on this now larger principal amount. So don't do a thing about money without thinking about it first.
Carol, you know that filer you borrowed?
Stop. Game is in the end. Used in conjunction to else.
Five,
4, 3, 2, 1.
Scale. Scale up, scale down. Not weighing scales, but scales of models, drawings and maps. Scale is simply the ratio of the length on a model to the length on the real thing. And we write scales like this: 1 to 20, or as 1 to 20, as 1 over 20, or as 1 centimetre represents 20 centimetres. Now, the distance between Gatwick and Manchester on the map is 12 centimetres, and the scale is 1 to 2.5 million. So, 12 centimetres on the map represents 12 multiplied by 2.5 million, which equals 30 million centimetres, or the distance from Manchester to Gatwick is 300 kilometres. Let's go on to areas and volumes. This square has been enlarged by a length scale factor of 3, but what has happened to its area? Well, it started with an area of 1 square unit, and its image has an area of 9 square units. The area scale factor is the square of the length scale factor. Likewise, the volume scale factor is the length factor cubed. Here's a question. A road tanker has wheels of diameter 1 metre. This area is 20 square metres, and the volume of the tank is 150 cubic metres. Say on a model you want to make the wheels 2 centimetres in diameter. The length scale factor is 2 centimetres over a metre, which is 2 over 100 or 1 over 50. So the area factor is 1 over 50 multiplied by 1 over 50, which is 1 over 2,500. The area of the end of the model is 20 square metres multiplied by 1 over 2,500, which equals 0.008 square metres. Now, there are 10,000 square centimetres in a square metre. So the area of the model is 0.008 multiplied by 10,000, which equals 80 square centimetres. Now, what about the volume? Well, there are 1 million cubic centimetres in a cubic metre. The volume of the model's tank is the volume of the real one multiplied by the volume scale factor, which is 150 multiplied by 1 over 50 cubed, which equals 150 divided by 125,000. And if you multiply that by 1 million to change it from cubic metres into cubic centimetres, you get 1,200 cubic centimetres. With maps, it's important to know what way up things should be. Finding directions is one of the best uses of this part of maths. There are 2 parts to understanding the maths of maps, and the first is bearings. A bearing is a way of giving a direction. Bearings are given as 3-figure numbers measured in degrees from the north, going in a clockwise direction. That is, you measure the angle from the north to the line showing the direction between the 2 points. The angle between the north and the direction line from O to X in this diagram is 80 degrees. So the bearing from O to X is given as 080 degrees. To find the bearing of a reverse direction, like XO, then add 180 degrees to the bearing of O to X. So the bearing of X to O is 80 degrees plus 180, which equals 260 degrees. However, if the original bearing was more than 180 degrees, then you subtract 180. Remember that we draw maps the way we do, so we'll all know how to read them. Don't assume something about a place simply because it's at the bottom of a map. Once upon a time, we in Britain had our own ways of measuring mass or weight, length and capacity. We used the imperial units. But all of Europe used the metric system, using metres, grams and litres. So, to make life easier, it was decided that we should use the metric system too. Now, the metric system is based around dividing and multiplying by tens. And yes, you've guessed it right. Here is another set of things to learn. Mass, 1 gram, is about the mass of 2 paper clips. 1 gram equals 1,000 milligrams. 1,000 grams equals 1 kilogram, and 1 metric ton is 1,000 kilograms. The longest measure of length usually used is the kilometre, which is equal to about 2.5 times around the Wembley football pitch. In every kilometre, there are 1,000 metres. In every metre, there are 100 centimetres, and in every centimetre, there are 10 millimetres. So, there are 1,000 millimetres in a metre. Units to measure capacity or volume are similar. 1 litre is divided into 100 centilitres, and 1 centilitre is equal to 10 millilitres. So 1 litre equals 1,000 millilitres. 5 millilitres is about a teaspoon. Now, say you had some biscuits. How many packets, each weighing 250 grams, can be made from 3.25 kilograms of biscuits? 3.25 kilograms is 3,250 grams. So the number of packets is 3,250 divided by 250, which makes 13 packets of biscuits. In maths, the word average has just a few very special meanings. There are 3 sorts of average: the mean, the mode, and the median, and you must know the differences between the 3. Take this example. A class of 10 children score like this in a French test. First of all, the mean, which is what most people think of as the average. The mean is the total of all the values in a list added together, divided by the number of values. So to find the mean here, you add up all the scores, which gives you a total of 52. And then you divide that total by the number of children who sat the exam, that is, by 10. So the mean score for the class was 5.2. The mode, however, is the value which appears most often. So the mode of the exam scores is 5, because that appears 3 times. The median is the middle value once the information has been arranged in order. In this example, there are 2 results in the middle, 5 and 5. So the median equals 5. However, if these middle values differ, say they had been 5 and 7, then you would take the middle of those, which would be 6. So we have one set of exam scores, but some different averages. A mean of 5.2, a mode of 5, and a median of 5. Because the mean, unlike the other averages, uses all the values, the mean is the average which gets used most often. Does this mean anything to you? This jumble of figures is called raw data, and it shows the marks given to pupils for an English exam. Now, let's divide them into reasonably sized groups of results, called class intervals. Once you've decided on those, you can count the number, or the frequency, of people in each class interval, and draw a table to show them. You can show this table in graph form by drawing a frequency diagram. Draw 2 axes, label the vertical axis frequency, and choose a scale so that the highest frequency is as near the top of the paper as possible. Label the horizontal axis marks and put on the class intervals. Now you can put in the data. You should end up with a frequency diagram which looks something like this. The modal class is easy to read from the frequency diagram, as it's the class with the highest frequency. In this case, 50 to 59. This table shows the favourite colour of a group of children. Another way of making the data clear is to use a pie chart. A pie chart is a circle divided up into segments. The first thing we need to know is the total number of children, which comes to 20. All the segments added together must add up to the number of degrees in a circle. That's 360 degrees. So, if there are 20 children, then for each child there must be 360 divided by 20, or 18 degrees for each child. You can now complete another column in the table to show how big each segment is. It's worth checking that all the segments add up to 360 degrees now before you draw it out. The pie chart isn't much good until all the segments are clearly labelled and the angles drawn in. And don't forget, give it a title. To find out if there's some connection between two things, like the height and weight of people, you could take a group of people and complete a table like this. Now, to convert these results into a graph, you should do this. First of all, draw the axes. I've chosen to put height in metres up the y-axis and weight in kilograms along the x-axis. Now you need to plot the points. Take each result from the tally table in turn and draw across exactly where the point should be. You should end up with a scatter diagram like this. Now, to draw a line of best fit, get a long transparent ruler and put it over the crosses. Using your judgment, line up the ruler so that roughly half of the crosses are above it and half of the crosses below. If there are any which are obviously miles out, then just ignore them. He loves me not. He loves me not. Oh well. Probability is a measure of how likely something is to happen. If something is absolutely certain to happen, it's given a probability of 1. If it will never, ever happen, then the probability is 0. For instance, if you have a pack of cards and draw the cards out at random, you can work out the probability of a card being a heart. The probability of an event, like picking a heart, happening is equal to the number of ways that event can happen, 13 hearts in a pack, divided by the total number of possibilities, 52 cards picked from the pack. So the probability of picking a heart from a full pack of cards is 13 divided by 52, which equals 1/4 or 0.25. If you threw a dice 90 times, how many times would it land as a 3? Well, dice can land in 6 different ways, so the probability of a 3 landing would be 1/6. So if you threw the dice 90 times, you'd expect a 3 to land 90 multiplied by 1/6 times, which equals 15 times. If 2 completely independent events are happening, then you can calculate the probabilities for particular results. If you need the probability of one thing and then another happening, you must multiply the probabilities. So the probability of throwing a 3 followed by throwing a 2 on the second throw is 1/6, the probability of throwing a 3, multiplied by 1/6, the probability of throwing a 2 on the second throw, and that equals 1/36. If you need to find the probability of one thing or another happening, then you add the probabilities. So on a single throw of the dice, the probability of throwing a 2 or a 3 would be 1/6, that's the probability of throwing a 2, plus 1/6, which is the probability of throwing a 3, which equals 2/6 or 1/3. However, things can get more complicated. If you toss a coin and throw a dice at the same time, what's the probability of either getting a head or a 6? Well, this time, write down all the possible outcomes, which is here, heads and 1, 2, 3, 4, 5, 6, or you have a tail and a 1, 2, 3, 4, 5, 6. Those are all the possible outcomes which can happen. Then highlight those which are specific to our event happening. So you either get a head That's 6 possible outcomes, or a 6 and a tail. The probability, then, is the number of ways this event can happen, which is 1, 2, 3, 4, 5, 6, 7. We write that in here, over the total number of possible outcomes, which is 6 and 6, which is 12. So the probability equals 7 over 12. What you must be sure of when you do these calculations is whether you add the probabilities or multiply them. If the questions start to get even more complicated, then you can always use a tree diagram. Say you were to toss a coin 3 times and you wanted to work out the probability of different sequences happening. This is what you would do. Take the first toss of the coin. You'll either have heads or you'll have tails. Then, say you toss the coin a second time. Add in more branches like before. Do this until you complete the diagram. Then, add in all the probabilities. Now, as one toss follows after the other and doesn't depend on the previous outcome, then all the probabilities are multiplied. A half multiplied by a half, multiplied again by half, is equal to 1/8. Now, when you've finished, it's worth adding up all the probabilities to make sure that they add up to 1. Yep, 8/8, that's equal to 1. Now, you can use this to find the probability of various things happening. What about 3 heads on the trot? Well, the answer there is 1/8. What about something a little more complicated, say 2 heads and a tail, but in any order whatsoever? Well, here are the possible outcomes. There are 3 of them, each with a probability of 1/8. So the total probability is equal to 3/8. No report or newspaper is without a chart or table of some sort. Governments, businessmen and scientists all make decisions with the help of information like this. So, knowing how to read a graph, chart or table and how to make them is really important. The simplest type of graph is a straight line, like this, this or this. The slope of a line is called its gradient. A line sloping upwards has a positive gradient, and one sloping downwards, a negative gradient. A horizontal line isn't sloping at all, so its gradient is equal to 0. If you have to calculate the gradient of a line on a graph, draw a right-angled triangle like this. To be accurate, though, make it as big as possible. Now, the gradient is calculated by dividing the vertical distance, which is 4, by the horizontal distance, 2. So the gradient of this line is 4 divided by 2, which equals 2. Now, all straight lines have the same basic formula. Y equals mx plus c. M equals the gradient of the line, and c is called the intercept. It's the value of y where the line crosses the y-axis, or where x equals 0. If you have 2 perpendicular lines, then the product of their gradients will be -1. Here, the equations of the lines are y equals 2x and 2y plus x equals 10. Well, first, put 2y plus x equals 10 into y equals mx plus c form to give y equals -1/2x plus 5. So, 2 multiplied by -1/2 equals -1. They're perpendicular. Now, to plot out a straight line graph, you need to know some points. The first thing to do is to draw a table like this. Once you've done that, then fill in the spaces. Now put them onto the graph. When you've finished, the points should all line up like this. If they don't, then you've made a mistake. So check the point which is obviously wrong. Now, take a long ruler and draw a straight line through all of the points. Make sure that your graph has a title and that both the axes are labelled. So much for straight lines. What about curves? Well, here's another formula. Y equals 2x squared. Now let's see what this line looks like. The first thing to do is again fill in a table, and I've chosen to take x from -3 to +3. But the values of y go from 0 to 18. So you've got to choose a scale which uses as much of your piece of paper as possible. Now to put on the points. The first point I have is -3, 18. So I start from the origin, -3 and up 18, and mark in the point. Now you might notice here that the scales I've used are different for the x and the y axis. Now the trick is to join the points with a smooth curve. Now you should end up with a curve like this, and this is called a parabola. And you'll get a curve like this if you have in the equation something multiplied by x squared. There is another curve you should be able to draw called a hyperbola. And here's an equation for one. Y equals 3 over x. Well, let's see what this looks like between x values of -3 and 3. You'll always get a hyperbola if the equation is y equals something divided by x. Finding the gradients of curves is slightly more difficult. Say you want the gradient of this curve at this particular point. To do it, you need to draw a tangent. Draw a long line which just touches the curve here, but it mustn't cross it. Now find the gradient by dividing this length, the vertical length, 6, by the horizontal length, 3. And when we do that, we find that the gradient at this point on the curve is equal to 2. If an equation is written as a function of, say, x, then you can solve it by drawing a graph. Solve this to find x when the function equals 0. The line you would plot is y equals x squared minus 2x minus 1, which looks like this. And the function is equal to 0 when the line crosses the y equals 0 axis. Think of putting fx instead of y. So the two solutions are x equals minus 0.4 and plus 2.4. What would you do if you had to find the solutions to these equations using graphs? Well, first of all, rearrange the equations so that y is isolated on one side, and then draw the two lines. So we have y equals x plus 2, that's the red line, and y equals 4x squared minus x cubed, that's the blue line. The solutions are the x coordinates where the lines cross. That's here and here. The formula for average speed is the total distance travelled divided by the total time taken. Now we can get more information by making travel graphs. This is a graph of a journey to the shops. On the y-axis is the distance, and on the x-axis is the time taken. The straight lines show a journey at constant speed, and from this you can see it took 10 minutes to travel the 800 metres to the bus stop, or 0.8 kilometres to the bus stop. There was a wait of 10 minutes going nowhere, that's the horizontal line, and you can also see exactly where the person is at any time. She was 3,000 metres, or 3 kilometres from home, after 32 minutes. The velocity is the gradient of the line. So the velocity of the bus was 2,200 metres divided by 12 minutes. Convert minutes into hours and metres into kilometres to give the velocity equals 11 kilometres per hour. A velocity time graph is different. The gradient of the line here gives the acceleration or the deceleration, and the area under the line is the distance travelled in a certain time. Here's a graph of a car's journey. The initial acceleration is the gradient of the first part. This comes out as 30 divided by 10, which equals 3. The units of the gradient are metres per second squared. If the graph slopes downwards like this bit, then the gradient is a deceleration. The car is slowing down. Remember that if the slope is 0, the car isn't stationary, it's going at a constant speed. Now, the area under this graph is the distance travelled. You can split it into 3 areas like this, and then calculate each one separately. We have the distances as 150 metres, 900 metres, and 225 metres. So the total distance travelled is then 1,275 metres. To find the average velocity, or average speed, divide the total distance travelled by the total time taken. So that is 1,275 metres over 55 seconds, which equals 23.2 metres per second.
Time.
4, 3, 2, 1.
A vector is a special quantity because it has both size and direction. A distance 2 kilometres at a bearing of 300 degrees certainly specifies size and direction, so that is a vector. Now, there's a special way of writing a vector. One from point A to point B is called AB and is written with an arrow above it. Or it has a name, A, in heavy print. You can also show that a normally printed letter is a vector by underlining it. Now, many vectors are drawn on graph paper. This one from A to B goes along 2 and up 1, and it can be written as a column vector 2, 1. The inverse or reverse of it is from B to A or minus A, and that is written as minus 2, minus 1 as a column vector. Two vectors are the same if they have the same column vectors. This means that they're the same length and in the same direction, but remember, it doesn't matter where they start from. The size or magnitude of this vector is written like this, and it's found by taking the horizontal and the vertical components, and then by using Pythagoras' theorem, we find that the size of this vector is the square root of 5. A vector can be multiplied by a number. This is A. 2A looks like this. You could also have 4A minus 3A, which is going in the opposite direction, or even a little half A up here. And this is what the column vectors look like. A equals 2, 1. So 4A equals 4 multiplied by 2, which is 8, and 4 multiplied by 1, which is 4. Now, all these are parallel, and the direction of all of them, apart from minus 3A, is still the same. Now, vectors can be added or subtracted. Let's add A and B. These are the column vectors. A is 3, 5, B minus 4, 3. Now, since you can have B wherever you like, you can draw it so that it starts at the end of A. So we have the vector A followed by the vector B. The sum is a vector from the start of A to the end of B, and it's called the resultant of A plus B. We're going to call it C. So A plus B equals the resultant vector c. And if we introduce the column vectors here, we can find c. c equals a plus b. Taking each one in turn, we have 3 plus minus 4. That gives us minus 1. 5 plus 3, and that gives us 8. So the vector c has a column vector of minus 1, 8. Subtracting vectors is nearly the same. A minus b means at the end of A you can draw b in the opposite direction. So we have A followed by minus b. We end up with a resultant vector d. So A minus b equals the vector d. And if we put in the column vectors, we have d equals 3 minus 4, which is 3 plus 4, to give 7, and 5 minus 3, which gives us 2. So the column vector of the resultant vector d is 7, 2.
Five,
4, 3, 2, 1.
Angles are made when lines cross one another. Where a pair of lines cross, 4 angles are made. The opposite angles have equal numbers of degrees. So A is the same size as C, and B is exactly the same size as D. When 2 lines never meet, they are called parallel. And parallel lines are marked with arrows. All lines marked with the same number of arrows are parallel. Lines are perpendicular if they make a right angle with each other. The locus of a point is a line which the point traces out following one or more rules. There are some that you should recognise. Say you want the locus of points 10 centimetres from here. Here's one, here's another, and here's another. If you draw many of them, then it clearly becomes a circle. The locus of points 10 centimetres from a line gives another line. And don't forget that there are 2 of them, one above and one below it. If the rule is that the points must be equidistant from 2 intersecting lines, then there are 2 loci, one here and one here. Try this. A ship is in distress at a position less than 15 kilometres from coast B. So we can draw our first locus. This is the locus, a straight line going up, which is 15 kilometres away from coast B. We know the ship is somewhere within this region. The Coast Guard station at A picks up its signal, and it knows that the ship is less than 20 kilometres away from the Coast Guard station. So we can draw our second locus. That locus is part of a circle with centre at A and a radius of 20 kilometres. Draw in that circle. So we know the ship is also within that circle. Where is the ship? Well, we know the ship is where these 2 regions overlap. This is where the ship might be.
Stamaty to video.
Dip up mandkicie.
Zatrzymaj taśmę.
Syste teleolam.
Stop the tape, lad.
Five,
4, 3, 2, 1.
Triangles have 3 sides and 3 angles. Is that it? Well, I'm afraid not. In maths, you talk about many different types of triangle, which you should know, and it will help if you revise our section on angles. A scalene triangle has no sides the same length and no equal angles. An acute angle triangle. Every corner is an acute angle. A right-angled triangle, one of the angles is 90 degrees. An obtuse angled triangle, one angle is greater than 90 degrees. Equilateral, all sides the same length, all angles the same at 60 degrees. When sides are of the same length, by the way, they're marked with a small line like this. An isosceles triangle has two sides the same length and two equal angles. An important thing to remember about triangles is that the angles always add up to 180 degrees. And I can show you this if I rip off the angles of this triangle and lay them out together. You will see that they make a straight line, and that is 180 degrees. The perimeter of a triangle is this. It's the distance all the way around, and you can find it by adding all the lengths of all the sides together. You might be asked to construct a triangle ABC, given some measurements. If you're given the three lengths, say 4, 5 and 7 centimetres, what you would do is this. Draw one of the lengths. I've chosen to draw CA and mark on the length of it. Next you need a pair of compasses. I'm going to mark in BC, which I know is 5 centimetres long. So I make the pair of compasses 5 centimetres. I put the point on C, because it is the line BC, which I'm drawing, and make an arc. The next thing I do is look at the other measurement, which is 4 centimetres. I push the compasses in to make 4 centimetres, put the point on A, and draw an arc. And where they cross is the point B of the triangle. Now all I need to do is fill in the lines, join B to C and B to A, and I have completed the triangle. You might be given two lengths and the included angle. And here we have two lengths, AB, 6 centimetres, BC, 8 centimetres, and the included angle, which is angle B, as 30 degrees. So draw one of the lengths. I've chosen to draw in BC, which is 8 centimetres. The next thing I want to do is measure off angle B, which I know is 30 degrees. So I bring in my protractor, put the centre line on point B and make sure that the protractor is straight along the line. Then I measure off 30 degrees. I'm going 0, 10, 20, 30, which is either on this point or on this point here. Next thing I need to do is join point B to one of these and draw it all the way through. Now, I know the length AB is 6 centimetres, so I measure from B along this line 6 centimetres, and that gives me point A. I connect A to point C, and so I have constructed my triangle. Quadrilaterals are four-sided shapes, and they too come in different types, each with their own names to learn. A trapezium has only one pair of parallel sides. A parallelogram has opposing sides of equal lengths which are parallel, and opposing angles are equal. The rectangle is a special parallelogram. All four angles are 90 degrees. Sides facing each other, that's opposite sides, are the same length. Again, notice how we mark sides of equal length. A square, all angles 90 degrees, and all the sides the same length. A rhombus has all sides the same length, and opposite angles are the same. A kite has no parallel sides, but it does have two pairs of sides of the same length next to one another, adjacent. Of course, you can have a quadrilateral with absolutely no angles or sides the same, all parallel. But with any quadrilateral, the angles always add up to 360 degrees. And I can show you. Let's take off all the interior angles of this quadrilateral. That's 1. That's 2. The third one, place that there. And finally, the fourth. And you can see that put together, they make a circle, which is 360 degrees. If the families of triangles and quadrilaterals aren't large enough for you, well, they themselves belong to an even bigger club. Any shape with straight sides, including triangles and quadrilaterals, are known as polygons. Things get more complicated when you get away from 3- or 4-sided polygons. This is a pentagon, 5 sides and angles. A hexagon, 6 sides and angles. A heptagon, 7 sides and angles. An octagon, 8 sides and angles. And these are all regular polygons, where all sides and all angles are the same. These are also polygons, but they are irregular. It may seem like a lot to learn, but you should know it. Now, the angle sum of a polygon is what you get if you add up all the angles inside the shape. Take a hexagon. We can divide it up from any corner into triangles, and here we have 1, 2, 3, 4 triangles. The angles in a triangle add up to 180 degrees. So all you have to do is count the triangles, we've got 4, and multiply that by the number of degrees in each triangle. So we have the total sum of the interior angles of the hexagon equals 4 multiplied by 180 degrees, which equals 720 degrees. Now, in a regular hexagon like this, there are 6 equal interior angles, A, B, C, D, E, and F. So each one must be equal to 720 degrees divided by 6, which equals 120 degrees. These are the interior angles of a polygon, and these are the exterior angles, where the lines have been extended. And it doesn't matter how many sides there are, the exterior angles of a regular polygon always add up to 360 degrees. Right-angled triangles are very important, and there are a few rules to learn about them. The first is called Pythagoras' theorem, where the lengths a squared plus b squared equal c squared. Now, in any triangle with a right angle, the side opposite the right angle is called the hypotenuse. Here it's labelled as C, and it's always the longest side in the triangle. Here's a question. If side A is 5 units and side B is 12, how long is the hypotenuse C? Put in the figures. A is 5 and B is 12. Now square the figures. Then they're added together. They give 169. So if c squared equals 169, c equals the square root, which is 13. The other rules concerning right-angled triangles are to do with their angles, and you must learn these too. This angle, let's call it P, has an adjacent side. It's adjacent to the right angle, and it has an opposite side. The ratio of the opposite length to the length on the hypotenuse is called the sine of the angle P. The ratio of the adjacent to the hypotenuse is called the cosine of angle P. The opposite divided by the adjacent also has a name, and it's called the tangent of angle P. Sine, cosine and tangent are often shortened to sine, cos and tan. One handy way to remember them is to remember the word SOHCAHTOA, SOHCAHTOA. The first letter of each word, sine, you have S, OH, CAH, TOA. Remember, SOHCAHTOA. Now, there are many questions which could be asked in an exam. In a right-angled triangle, PQR, angle R is 90 degrees. PQ is 8 centimetres and QR is 5.6 centimetres. What is the size of angle P? Well, we could calculate it like this. Sine P is the opposite over the hypotenuse, which is 5.6 divided by 8. On your calculator, you get 0.7. Now, to find P, press the inverse button on your calculator, then the sine button, and that gives us the angle P equals 44 degrees to the nearest degree. If you're given an angle and the hypotenuse, you can find the opposite or adjacent lengths by rearranging the formulae. Opposite equals hypotenuse times sine, adjacent equals hypotenuse times cos, and opposite equals adjacent times tan. The most important thing to do to answer a question with trigonometry is to draw a good diagram first. Get as much information as possible from the question. Here's an example. This is a pyramid with a rectangular base and a vertex E vertically above A. Let's work out the length EA. Look for a right-angled triangle, and we have EAB as a right-angled triangle. Now we know the angle B and its adjacent length, and we need to find the opposite. So we use the tangent equation. EA equals 4 multiplied by the tan of 52.3 degrees, which equals 5.18 metres to 3 significant figures. What about the angle ECA? Well, you can see that ECA is a right-angled triangle, but we don't know the length AC. No problem, we can find it. Look at the base AC. Now that is the hypotenuse of the triangle ABC. So using Pythagoras, we have AC squared equals 4 squared plus 3 squared, which works out as AC equals 5 metres. Now we can draw this triangle EAC and calculate the angle ECA by using tangents again. Use the inverse tan button on your calculator to give the answer 46.0 degrees to 3 significant figures. The trick to these questions is to find the right-angled triangles. If you need a dimension or an angle, see if you can work it out by looking at another triangle. We have to know how to talk about circles. These are names you should simply learn and understand. A line is a tangent if it just touches the circle at one point, the point of contact. This is the circumference C going all the way around. Any part of the circumference is called an arc. There's a minor arc and a major arc. A chord divides a circle into a major segment and a minor segment. Two radii split up the circle into a minor sector and a major sector. To calculate the area of a circle, use the formula area equals pi r squared, which you should also know. So for the circle of radius 6 centimetres, the area is 3.14, or press the pi button on your calculator, multiplied by 6, which equals 113.04 square centimetres. This wheel has a diameter of 50 centimetres. What is the distance 60 degrees around? Well, first, calculate what fraction of a circle that is. There are 360 degrees in a circle, so you've gone 60 divided by 360, or 1/6 of the way around. So the length of the arc is 1/6 of the total circumference, and substituting in the value for the radius of 25 centimetres, we have 26.2 centimetres. You can use this method to calculate the areas of sectors. If you wanted the area of this bit of cake, you could easily calculate the area of the whole cake and multiply it by the fraction of the circle. So the fraction here equals 40 over 360, which equals 1/9. So the area of this sector equals 1/9 multiplied by pi multiplied by 20 squared, which equals 140 square centimetres. More things to learn, I'm afraid. If you have a semicircle, then this angle is always a right angle. The radius to a point of contact of a tangent is at 90 degrees to the tangent. If you see any figure like this, then this angle is always twice this angle. The opposite angles in any quadrilateral drawn in a circle add up to 180 degrees. A line from the centre of the circle is perpendicular to a chord if it passes through its midpoint. Equal length chords are the same distance from the centre. These two tangents are the same length, and these pairs of angles are the same.
Five,
4, 3, 2, 1.
A shape is symmetrical about a line when one half of it is a reflection of the other half, a reflection about a line of symmetry. Take a few things in nature. Transformations are made up of rotations, reflections, translations, and enlargements. A translation is when you move a shape up a bit or down a bit and along a bit. The shape doesn't change size, it isn't rotated, it simply slides. This shape has been translated 8 units to the right. Now, some translations are given by a vector like this, which means 6 across and 4 down. If you're given half the picture and its line of symmetry, this one's going up here, then you can complete the reflection. What you do is, here, this point is on the line of symmetry, so that is A and also A dash. And going down here, E is on the line of symmetry, so E dash is in exactly the same place. But what about B? Well, you measure out how far B is from the line of symmetry. This is 2 blocks. And then, as long as this line makes 90 degrees with the line of symmetry, you draw it out and make another 2 blocks this side, and that gives you the position of B on the image. You do the same for C. C is 4 blocks away, so that is C dash. And D down here, that's 4 blocks away, so that's 1, 2, 3, 4, D dash. Now you fill the whole thing in, so you draw from A dash to B dash, B dash to C dash, C dash to D dash, and complete it with a line from D dash to E dash. And there you have your reflected picture. If you were asked to rotate this triangle ABC around a point X and take it through 90 degrees, then you would take each point in turn. So let's say we look at point B first of all. You would measure the distance from B to X and draw in a line. Then you would measure a 90-degree angle and draw a line from X to B dash. Now the distance from X to B dash has to be exactly the same as from X to B. And you would do this for A, B and C, and that will give you your rotated triangle A dash, B dash, C dash. There is another type of symmetry which is called rotational symmetry. This diamond shape can be rotated about its centre so that it looks the same in its new position. It only looks the same in 2 positions, so we say it has rotational symmetry of order 2. An enlargement simply changes the size of a shape. To enlarge something, we need to know the scale factor and the centre of enlargement. Let's enlarge this triangle by a scale factor of 2 from the point 2, 2. Draw a line from the centre of enlargement of each corner and measure its length. Multiply it by the scale factor, in this case 2, and measure this distance from the centre of enlargement along the same line. This is the new corner of the enlarged triangle. Do this for all corners and then join them up. You should get a similar but bigger triangle. Notice that the angles are exactly the same size. The centre of enlargement doesn't have to be outside the shape. It could be on it, or it could be in it. A scale factor can also be less than 1 to give a smaller shape. You can work out the scale factor from an enlargement by measuring corresponding lengths and using this formula. Scale factor equals image length over object length. So, in this case, the scale factor is 2.5. You can also find out the centre of enlargement. Draw a line joining the corresponding points on the object and the image and extend it. Draw another line through a corresponding pair. Where the lines cross, that's the centre of the enlargement. One transformation is sort of easy enough, but there might be more than one. The trick is to draw an accurate diagram to see clearly exactly what's going on. Carefully draw the first image, and then the second image, and so on, until you complete the question.
Five,
4, 3, 2, 1.
The complicated shapes of the real world are often built up from simpler solids or shapes. A cube, a cuboid, cylinder, cone, or a pyramid. If a rectangle has measurements of 5 centimetres and 4 centimetres, the area is found by using this formula. Area equals length multiplied by breadth or width, and you should know this for the exam. Now this rectangle has an area of 4 centimetres multiplied by 5 centimetres, which equals 20 square centimetres. Now notice that it's said as 20 square centimetres and not ever as 20 centimetres squared, which is equal to 20 multiplied by 20, which is 400 square centimetres. How do we calculate the area of a parallelogram? Well, take this triangle and stick it on here. Now, the parallelogram has changed shape to a rectangle, but it hasn't changed its area. So, the area of a parallelogram is simply the length of the base multiplied by its height. And you can use the same formula for parallelograms of any shape, even ones like this. Now, a shape like this is called a trapezium. The area can be calculated by changing the shape again. If we slice it in half, halfway up, then turn this bit over, the trapezium becomes a parallelogram. So the area of the trapezium equals a half multiplied by a plus b in brackets multiplied by h. Whenever you have a complicated shape, always look for easier ones like rectangles, triangles and circles to calculate. Remember, some shapes have holes cut in them, so you may need to calculate the shapes of the holes to subtract. When measuring volumes, we talk about cubic units. Now, 1 cubic centimetre has a shape like this. It's 1 centimetre by 1 centimetre by 1 centimetre. The formula for the volume of a cuboid is length multiplied by breadth multiplied by height. So the volume of this solid would be 10 multiplied by 6 multiplied by 4, which equals 240 cubic centimetres. For some strange reason, an architect wants to build a concrete shape 20 metres long and with a cross-sectional area like this. Now, a lorry can carry 200 cubic metres of ready-mixed concrete, but the architect can only order in whole numbers of lorries. His concrete company won't deliver part loads. So how many lorry loads should he order? What a problem. Now, think what you have to do. You first need to find the volume of the shape. The formula for any volume with a constant cross-sectional area is simply the area of the cross-section multiplied by the length. Now let's make the end simpler by cutting it into 2 to form a parallelogram and a trapezium. The area of the parallelogram is 6 multiplied by 5.5, or 33 square metres. The area of the trapezium is a half multiplied by 6 plus 8 multiplied by 4, and that works out as 28 square metres. So the total area is 33 plus 28, which is 61 square metres. So the volume is 61 multiplied by 20, which is the length, or 1,220 cubic metres. Now, if one lorry can carry 200 cubic metres, then the number of lorries needed must be 1,220 divided by 200, which equals 6.1 lorries. Well, you can't have a part load, so you better make it 7. Now, the formula for the volume of a cylinder is V equals pi r squared L. The volume of one of these things, a cone, can be found by using the same formula as any pyramid. The volume of any pyramid equals a third multiplied by the area of the base times the height. So the volume of a cone equals a third pi r squared h.
Five,
4, 3, 2, 1.
Formulas, or formulae, as some people call them, have rules which you've got to know. The first rule: unlike terms, such as a squared b and ab squared, can't be added. But like terms, 3ab plus 4ab can be added, and that would give 7ab. Now, try multiplying these terms. 3xy multiplied by 4xy squared z. Just write one term down after the other, which gives you this, and then multiply the numbers. 3 multiplied by 4 gives you 12. Collect your x's, your y's, and your z's, and you get the answer 12x squared y cubed z. Division is very similar. With terms on top of each other, the variables cancel down like this. 6xyz squared divided by 2xy squared z. You can cancel a 2 and a 2, x, y, y, z, z, and that gives you the answer 3z over y. There may be brackets around some terms, and you might need to multiply them out. Remember that each term in one bracket multiplies each term in the other. So here we have x plus 3 multiplied by x minus 2. Now it's best to draw the lines between the terms like this. X multiplied by x gives us x squared. X multiplied by minus 2 is minus 2x. Then we look at the plus 3. 3 multiplied by x gives us plus 3x. And finally, plus 3 multiplied by minus 2 gives us minus 6. We can now simplify this to say x squared minus 2x plus 3x is plus x. And then we have minus 6 at the end. Linear equations have only a letter like an x or a y, and no squares or cubes like y cubed. And you could be asked to solve one. That is, to find the value of the letter. So to do that, isolate all the terms with letters on one side and all the numbers on the other. Now, anything you do to one side of the equal sign, you always have to do to the other. Here we have two x's and a division. The first thing to do is to remove the division. Multiply both sides by 5. And this gives 3 minus x equals 5x. To get all the x's on one side, it might be best to get rid of this minus x by adding x to both sides. Well, let's see where we end up. 3 minus x plus x equals 5x plus x. Well, these cancel out, and we're left with 3 equals 6x. We want to get rid of the 6, so we divide both sides by 6, giving the solution x equals 3 over 6, or 1/2. And always leave your answers to these as fractions. Inequalities. These are where the quantity of, say, x, or the function of x, might not be equal to a number. This means x is less than 4, y is less than or equal to 7, t is greater than -3, s is greater than or equal to 0. Just like with equations, with inequalities you can add, subtract, multiply or divide by anything you like, as long as you do the same thing to both sides. But one thing you must remember is that if you multiply or divide by a negative number, then you reverse the direction of the inequality. So a greater than would become a less than, and a less than would become a greater than. Now, you can show an inequality as a region on one side of a line on a graph. First, draw the line. We have y equals 2 minus x. Next, choose an easy coordinate, like 0, 0. Put those values into the inequality and see if it's correct. Well, 0, 0 is wrong. So it's the other side of the line that we want. Now this is the area we're going to shade. However, sometimes you may be asked to shade in the other side, so make sure you read the question properly. Now one thing to remember is if the sign is greater than or less than, the line is dotted and a valid point can't be on the line. But if it's less than or equal to, or greater than or equal to, it's drawn as a solid line, and the points on it are included in the region. If you have an expression, then you might need to write it as the product of two factors. Here's an example of a quadratic equation. X squared minus 2x minus 24. Now this equals x plus or minus something in a bracket multiplied by x plus or minus something else in another bracket. What are the somethings, or the factors, to use their proper name? Well, to find them, the trick is to look at the original equation. The pair of numbers you're looking for must multiply to give minus 24, and they must add together to give minus 2. So try a few out. Let's try minus 8 and 3. Minus 8 times 3 is minus 24, that's okay. But minus 8 plus 3 is minus 5, so that's wrong. What about minus 6 and 4? Minus 6 times 4 equals minus 24. And minus 6 plus 4 equals minus 2, so they are the factors. X squared minus 2x minus 24 equals x minus 6 multiplied by x plus 4. If the expression is like this, 3x squared minus x minus 2, the best way of doing it is to start like this. Put the brackets down and write in 3x and x. Now what you need to find are the factors of minus 2. Well, they are 2 and minus 1, or minus 2 and 1. So let's try them out to see which pair works. Don't forget that there are 4 choices. So let's look at these. And we find that this gives the correct solution. If you're told that 3x squared minus x minus 2 equals 0, then to find x, take each bracket in turn and say that 3x plus 2 equals 0, which gives x equals minus 2/3. Also, x minus 1 equals 0, which gives x equals 1. So, x equals 1 or minus 2/3. One important factorisation is when you have one square minus another, like a squared minus b squared. The factors are these, a plus b and a minus b. Sometimes you have to look for the squares, like the volume of a pipe. Pi r squared h minus pi little r squared h. First of all, take out the pi h to give pi h r squared minus little r squared, which gives pi h r plus r, r minus r. Now we get on to solving simultaneous equations like these. 2x plus y equals 10, x minus 2y equals minus 5. To find what x and y are, we have to get an equation with only x or y in it. Watch this. Move the equations around like this. Let's eliminate x first. So look at the second equation and make the coefficient, the number in front of x, the same as the first equation. If the whole of the second equation is multiplied by 2, then it becomes 2x minus 4y equals minus 10. We can now take them away to get rid of x. 2x minus 2x is nothing. Y minus 4y is y plus 4y, or 5y. 10 minus 10 is 20. 5y equals 20, so y equals 4. To find x, put this value for y into any equation. So 2x plus y equals 10 becomes 2x plus 4 equals 10, 2x equals 6, x equals 3. An algebraic fraction is just like an ordinary fraction, but the numerator and the denominator can be letters or expressions. They follow the same rules as ordinary fractions. The first thing to do is to see if they can be simplified. 3 times x squared minus y squared over 2 times x minus y. Remember all the rules we've done before for factorising. Factorise the top to give 3 times x plus y times x minus y over 2 times x minus y. Then cancel down to give 3 times x plus y over 2. Addition and subtraction are a bit more difficult because you have to make sure that the denominators are exactly the same. 2x over a squared minus x over 3ab. Let's make both denominators 3a squared b. So we have 3b multiplied by 2x over 3a squared b minus ax over 3a squared b. Now subtract them to give 6bx minus ax over 3a squared b. Again, don't forget to factorise the answer if that's possible. So we have x times 6b minus a all over 3a squared b. What's next, lads?
Well, that's it, actually. Finish.
Oh, I was just beginning to enjoy myself there.
You're weird. Cut!
What did he do? Congratulations, no more to learn. By now you should have paused, rewound and stopped the tape more times than I can count. But just as long as you understand all of the topics, you should have achieved a standard suitable for GCSE higher level. Now there may be some coursework in your exam, so do check with your teacher to see that you've covered everything. Some syllabuses may also have covered a couple of extra topics. If you are studying those, then check again with your teacher. When you take the exam, you will be able to take in a calculator, but it's absolutely vital that you show all your working out, otherwise you'll just throw away marks. You'll also be given a formula sheet in the exam, so get one from school beforehand so that you know what information is on it and where. Also, try out a few examination papers because you'll get used to the layout and the different types of questions asked. It could be invaluable practice. So, on the day, don't forget to take in a calculator, batteries for your calculator, a ruler, pencils, a couple of pens, a pencil sharpener, a rubber, a pair of compasses, a set square and a protractor. Now you should be totally equipped both with the knowledge and with the kit. So I wish you all the best and hope to see you again sometime. Bye-bye.
6, 2, 3, 1, 4,
7, 5,
9, 8, 12, 15, 13, 16, 14, 34,
1029.
1.
1.